In this lesson entitled Rules for Differentiation, I'm going to refer to it as Day 2 of Lesson 3.3. We're going to learn new rules. Now, do not start this section until you're very, very comfortable with the basic derivative formulas. So be sure that you finished up all of Lesson 3 the first day, all of those problems on the worksheet that I gave you, and you're very comfortable. And then look at this lesson. Okay, so we've got 3 new rules. So the only thing you were able to take a derivative of so far is if you have a sum or a difference. If you have a polynomial expressed as a sum or a difference. Now we're going to learn 3 new rules, which will be the product rule, the quotient rule, and the power rule. So we're just going to go ahead and start with the product rule. Now I'm going to have some funny ways to teach this, so I hope you'll bear with my little nerdiness here. But for the product rule, I've got u times v. So u and v are 2 different functions. So I'm multiplying 2 functions together. So y is u times v. dy dx, the derivative is u times dv dx plus v times du dx. I'm going to say that again. The derivative dy dx is your first function u times the derivative of the second function v plus the second function v times the derivative of u. So we're going to say first derivative of second plus second derivative of first. Right, so let's look at that again. So it's your first function times the derivative of the second plus your second function times the derivative of the first, when u and v are 2 different functions and you have a product. So this is my product rule. Now all I'm going to ask you to do is to set up the derivative. I don't want you to go any further with it. You're not going to have to find a second derivative. So my practice with you guys right now is just, can you set up the derivative and stop? So don't feel like you have to simplify it all. I have the product. I have 2x plus 3 times x minus 5. Yes, I could FOIL it out and come up with a binomial, or excuse me, a trinomial, a polynomial, and then take the derivative of each piece. But I want to practice my product rule. So dy dx is equal to, now my first polynomial is 2x plus 3. My second polynomial is x minus 5. So I'm going to use that little trick. First times the derivative of the second, which is just 1. The derivative of x minus 5 is 1. Plus the second, x minus 5 times the derivative of the first 2. All right, this is all that you guys are responsible for right now for me, because I just want you to practice with the rules. So it's the first polynomial, 2x plus 3 times the derivative of the second. The derivative of the second, x minus 5 is 1, plus the second, x minus 5 times the derivative of the first. The derivative of 2x plus 3 is 2. Now, we know that we could do some math with it and simplify it, but again, I just want you to practice the rules. So first times the derivative of the second plus second times the derivative of the first. That's your product rule. So here's the second example. I have a trinomial times a binomial. Yes, we could multiply it out, but it's way quicker to find the derivative this way. Dy dx is equal to, this is my first, this is my second. So it's my first polynomial, x squared plus 3x minus 4, times the derivative of the second, 2x, plus, always a plus sign, my second, x squared minus 9, times the derivative of the first, 2x plus 3. And again, that is all you guys are responsible for right now. We'll worry about simplifying later. So first, x squared plus 3x minus 4 times the derivative of the second, 2x, plus the second, x squared minus 9 times the derivative of the first, 2x plus 3. And that's 2 examples of the product rule. Now, from the product rule, it makes sense that we're going to go straight to something called a quotient rule. So now I have a quotient rule, so we know that we've got division. I have a polynomial u divided by a polynomial v, and u and v are both functions, so it's like a rational function, and I'm going to take the derivative. You cannot take the derivative of the top, derivative of the bottom, and leave it. That's not how it works. So you have to use the quotient rule, which is the bottom v times the derivative of the top, du dx, minus u, which is the top, times the derivative of the bottom, all over the bottom squared. Okay, so look at that again. Use the numerator, v is the denominator. So it's the denominator times the derivative of the numerator minus sign here, the numerator times the derivative of the denominator all over the denominator squared. Now, I have all kinds of rules for this one, so I'm going to call u the top and v the bottom. And again, it's just memorization here, trying to help you remember it. So I'm going to say bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, if that's a little bit easier. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, I also had this really funny professor at ETSU who said the top was high and the bottom was ho. Okay, this is just how he remembered it and taught us to remember it. So let the top be high because it's on the top, and the bottom be ho because it's below. And he said, ho d high minus high d ho all over ho ho. Now, I thought that was funny and it was cute, but this is honestly the way I remember it. The bottom times the derivative of the top minus the top times the derivative of the bottom, but whichever one is easier for you. All right, so here's an example. I have a quotient, y equals 3x over x squared plus 7, so I've got a rational function. This is my top. 3x is my top, of course. X squared plus 7 is my bottom. And dy dx, again, just set it up. You do not need to do anything to simplify. I just want you to set it up. So it's the bottom, x squared plus 7, times the derivative of the top, 3. Always a minus sign here. The top, 3x, times the derivative of the bottom, 2x. All over the bottom, quantity squared. Okay? Bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Ho d high minus high d ho, all over ho ho. All right, my second example, another rational equation. Y equals x plus 1 over x squared plus 4x plus 4. There is no way to do this except to use the quotient rule. So again, you cannot take the derivative of the top, derivative of the bottom. It doesn't work that way. So we've got to go bottom, x squared plus 4x plus 4 times the derivative of the top, 1, minus the top, x plus 1, times the derivative of the bottom, 2x plus 4, all over the bottom quantity squared. X squared plus 4x plus 4 quantity squared. So bottom times derivative of the top, 1 minus the top, x plus 1 times derivative of the bottom, 2x plus 4, all over the bottom quantity squared. So you've learned the product rule, you've learned the quotient rule, and now we're going to go to the power rule. Okay, so when we go power to power, this is what we're thinking about now. If I have a function taken to a power and I don't want to multiply it out because maybe it's to the 5th power or 6th power and it's just kind of ridiculous to multiply it out, then I have a rule. And it's really similar to the rule you already know. You just have to remember to do this part right here. So remember that u is a function and I have u to some power n. So to find dy dx, I bring n down. I keep u exactly what u is to the 1 less power. Then I take the derivative du dx. So it's the derivative of the inside. So I'm going to call this the inside all the time. So you're going to, again, keep your function to the 1 less power. You bring your exponent in front. Function to the 1 less power, then the derivative of the inside. So this one I don't have much to say here except this is the derivative of the inside. So I'm going to mention that a lot. All right, and I think the best thing to do here is to look at an example. So I've got y equals 3x minus 5 quantity cubed. I could write down 3x minus 5, 3x minus 5, 3x minus 5. Foil the first two, distribute the last one, and then take the derivative of each of the pieces. But I want to practice on the power rule here. So dy dx is equal to, bring the exponent down, keep the function to the 1 less power, so that would be to the second, and then multiply by the derivative of the inside, which is 3. So this extra 3 is what everybody misses, if you can guess. They forget to take the derivative of the inside. So bring the 3 in front, keep the function to the 1 less power, and then take the derivative of the inside. All right, my second example, you may look at and go, that's really not a power. So I have to remember how to rewrite this as a power. This is the same as x squared plus 6x plus 5 to the 1/2 power. Okay, so now it looks like it's supposed to. Forget about this one. It is to the 1/2 power, so my derivative is, bring the 1/2 in front. Keep this function to the 1 less power. Now 1/2 minus 1 is negative 1/2. Then take the derivative of the inside, 2x plus 6. So bring the exponent to the front, keep the function to the 1 less power, negative 1/2, times the derivative of the inside, 2x plus 6. Now, if you had to simplify this, which, guys, we're just practicing on the rules right now. We don't have to simplify. Remember, negative exponents would say put this on the bottom. So you would have 2x plus 6 over 2 times the square root of x squared plus 6x plus 5, the negative 1/2 taking it to the bottom. So there's the 3 rules. Now, they don't look too bad when you look at them individually, but we can embed these rules inside inside of other problems, so let me just show you some examples. I don't remember how many examples I have here, not as many as the first lesson, but I just hope you're getting really good at it. So what I need you to do is to look at each problem and go, oh, I know which rule I'm using. So if you look at the first three with me, the first one is going to be quotient rule, the second one's power rule, and the third one's power rule. So you have to get really good and quick at which one you're going to use. So I am going to use the quotient rule, so I'm going to call this top, bottom, and you can go back and look at your notes if you need to. dy dx is the bottom, 1 minus x squared, times the derivative of the top, 2x. There's always a minus sign whenever we're doing the quotient rule. So it's then the top times the derivative of the bottom, negative 2x. And you'll have to be careful with those signs whenever you start simplifying. All over the bottom, quantity squared. So 1 minus x squared, quantity squared. Again, it's bottom, 1 minus x squared times the derivative of the top, 2x, minus the top, x squared times the derivative of the bottom, negative 2x, all over the bottom, quantity squared. All right, my second example is x squared plus x plus 1 quantity cubed, so that's a power rule. So the power rule says bring the exponent to the front, keep the function to the 1 less power. So that would be to the second power. Then don't forget to take the derivative of the inside, 2x plus 1. And again, what does everybody forget? The 2x plus 1. So be sure you go back and take the derivative of the inside. Bring your exponent to the front, keep the function to the 1 less power, times the derivative of the inside. All right, we have another quotient, or excuse me, power rule. For example, number 3, I have x cubed plus 1 to the 1/3 power. So bring the 1/3 to the front, x cubed plus 1 to the 1 less power. 1/3 minus 1 would be negative 2/3. Don't forget the derivative of the inside, 3x squared. And again, if you were going to simplify this, the negative exponent would tell you this whole thing goes to the bottom. So there's the first 3 examples. Nothing interesting, nothing tricky. All right, let's look at example number 4. Number 4 has a product rule, excuse me. So I've got 2 things I'm multiplying together. It's a product. So I'm going to go first and second. Go back and review that rule if you need to. dy dx is first times the derivative of the second, plus, always a plus sign in the product rule, second times the derivative of the first. So it's first, x squared plus 5x plus 4, times the derivative of the second, 6x minus 7, plus the second, 3x squared minus 7x plus 1, times the derivative of the first, 2x plus 5. Okay? First, x squared plus 5x plus 4 times the derivative of the second, 6x minus 7 plus the second, 3x squared minus 7x plus 1 times the derivative of the first, 2x plus 5. All right, now here's the tricky one. So I know on the first 4 we did, it was pretty easy to pick out which rule I'm doing. But on number 5, you have to look at it from the big picture. It's like, what is this? So it's a product rule with embedded power rule. Or we could change this to x plus 1 quantity squared over x squared plus 2x quantity squared. Because, guys, remember, negative exponents being put on the bottom. So we're going to say it's a product rule with embedded power rules, or it's a quotient rule with embedded powers, or, since they're both squared, we could say this is the same as x plus 1 over x squared plus 2x quantity squared. So then we would have, you got it, a product rule with an embedded quotient. So we just sometimes have to stick things together. Now, it's absolutely up to you the way you do the problem. I'm going to do this one by the way it's set up and just say, okay, that means power rule. So here's my first. Here's my product rule. Here's my second. So the way they have it set up, product rule with the embedded power. So dy dx will be first x plus 1 quantity squared times the derivative of the second. Okay, to take the derivative of this, I bring the exponent to the front. I keep the function to the 1 less power. Negative 2 minus 1 is negative 3. And I don't forget to take the derivative of the inside, which would be 2x plus 2. Okay, that's just the first part of the product rule. First times the derivative of the second. So x plus 1 quantity squared plus, or times the derivative of the second, bring down the negative 2, keep this to the 1 less power, 2 minus 1 is negative 3, and then take the derivative of the inside, 2x plus 2. Now, always addition whenever you're doing product rule. Now, it's the second x squared plus 2x minus 2 times the derivative of the first. So taking the derivative of this, bring the 2 down, keep x plus 1 to the 1 less power, so that would be to the first, times the derivative of the inside, which is 1. So that's how I would do the problem if I was using the product rule. If you would like the alternate, let's go this direction with the quotient rule, dy dx. Okay, so I'm just looking at it now this way and saying, what if I did quotient rule with the same thing? Because some people like the quotient rule better, believe it or not. So the quotient rule would be bottom x squared plus 2x quantity squared times the derivative of the top. So I'm taking the derivative of the top, bring the 2, x plus 1 to the first power times the derivative of x plus 1, which is 1, minus, because there's always a minus sign in the quotient rule, the top, x plus 1 quantity squared times the derivative of the bottom. Now, when you take the derivative of the bottom, it doesn't matter that this is on the bottom. You just go with what it is. So it's 2, don't worry about the negative part, times x squared plus 2x to the 1 less power times the derivative of the inside, 2x plus 2, all over the bottom quantity squared. So you have x squared plus 2x squared quantity squared, so that would be to the 4th power. So again, if I decided that I don't want to do the product rule, and I know that this is negative, so it goes to the bottom, I could do the quotient rule. And if I simplified, if I did my algebra correctly, these two would simplify to exactly the same thing. So if you did quotient, bottom, x squared plus 2x quantity squared times the derivative of the top, 2 times x plus 1 times 1 minus the top, x plus 1 squared times the derivative of the bottom, 2 times x squared plus 2x to the first power times the derivative of the inside, 2x plus 2, all over the bottom squared. All right, so last scenario. What if you went, okay, that's the same as x plus 1 over x squared plus 2x quantity squared. Then how in the world would you set that up? Well, you would have the power rule with the quotient rule in the middle. So you may never want to do this, but you may have to do this at some point. So if that's the case, you would bring the 2 down. You would keep your function, x plus 1 over x squared plus 2x. I don't know why I put a bracket. You could put a parenthesis to the 1 less power, so that would be to the first power, because then it would be times the derivative of the inside. And the derivative of this would cause you to do, you got it, quotient rule. So that would be, and these can be parentheses, they don't have to be brackets, but it would be bottom x squared plus 2x times the derivative of the top, 1, minus the top, x plus 1, times the derivative of the bottom, 2x plus 2, all over the bottom, quantity squared, x squared plus 2x quantity squared. So I guess, honestly, it's better to put the brackets because you have all the parentheses to show the multiplication. So one more time, if you decided to look at this as a power, so as a rational function taken to a power, a quotient taken to a power, you would have to do the power rule. Bring the 2 in front, keep the function to the 1 less power, which would make it to the first. Then don't forget to take the derivative of the inside, which is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom quantity squared. And one more time, if we did our algebra correctly, regardless of whether we did product rule, changed it to a quotient, did quotient rule, changed it to a power and did power rule, we'd end up with exactly the same derivative. So that's the beauty of math, right? You get to pick the ways easier for you. Now, I've already put this in your assignment, so you have assignment 3.3 for day 2. This will be a week-long assignment by the time you get through all of 3.3. So you've got 3.1, 3.2 to read. You have 3.1 day 1. You have, 3.3 day 1. You have 3.3 day 2. I'm going to put 2 quizzes in here for you to be sure that you understand the material. And this will be a week-long assignment. So good luck with this. Please email the questions. That's what I'm here for. Email the questions. And I appreciate those of you who have. I've started working problems with some of you, like via email. I'm happy to do that. So please, let me know if you need the help. Good luck.